So now we're going to look at reaction coordinate diagrams. So right here, we're going to get into how these bonds are like partially formed bonds, partially broken bonds. So we have the nucleophile right here, right? Actually, let's use that. Nucleophile right here, and U minus. Hello? The hydrogen is the S plus. We are reaching over, grabbing that hydrogen, and we are going to break a bond, right? So that's what this dashed line shows right here, is a bond breaking. Then we are making that hydrogen bond, right? So partially formed bond, but we are also breaking that bond between HBr, right? And then we end up with a CH3 plus CH2CH3, right? And then the Br minus is right here. We can, because we have that plus, because carbon is willing to accept more, this is a E plus, what did I say was up there? Yeah, S plus, comma, E plus. And then this is Nu minus, reaches over and grabs that. We have no bond breaking occurring, only bond making, right? And so we've made that bond right there, and that gets rid of that plus on the carbon and gets rid of the minus on the bromine, because the bromine shares its electrons and the carbon gains some electrons, making everything happy, right? So this right here symbolizes the transition state, okay? This is the transition occurring. This is being turned into this, and this is being turned into that, okay? So that is the transition state, and we constantly want to be showing the partially formed and the partially broken bonds, okay? Did I just do this? I did just do this, okay. So right or wrong? Yeah, so we are breaking that because that's our nucleophile. We are making the bond between the hydrogen because this is our electrophile, which should be written as E plus. And then in here, we have, wait, why did we do that? S plus. Okay, yeah, that makes sense. S plus, right? Because the carbon bond is breaking, so this is going to be plus now. And it's making that bond between carbon and hydrogen, and it's breaking that bond between hydrogen and bromine. So we're kind of just showing it all in one big step. So S minus and S plus are in transition states, and they have to be included, okay? And that is what's going to give us this, and then we plug that into here, 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 okay? So this reaction right here, right, this is products. And because the energy is high, that means the concentration is low, right? So it's going to be 1/2 Ke is less than 1, and that is endergonic right here, okay? Which is shown by positive delta G 0. And we know that is positive delta G 0 because, how do we know, right? High, this is, oh, sorry. Whoa, give me a second. So this is 2 products minus reactants equals 1, right? And so that's delta G 0 because we're doing the energy of the products minus reactants. And that is why we have a positive delta G 0. Carbocation product is less stable than the reagent, right? Because it's less stable than the reagent because it has a higher energy. So we can also just tell that without even having to do the math or anything because we see it right here. So delta G plus is large energy of activation, meaning it's slow, okay? That is very high up. That is a slow reaction. And generally with slow reactions, we have to add heat so that it kind of fastens up a little bit, right? So high free energy equals low concentration, which is what we initially did to figure out the endergonic. And then we have the transition state of the next, right? So we're looking at the second reaction going from here to there to there. Plus, and all of those are present, right? The bond is being made, bond making, right? So in this case, the products are more stable. It is exergonic, negative delta G, because the free energy is low, meaning the concentration of the product is high. So that's 2 over 1 equals 2, and then K equals is greater than 1. So in this case, yeah, it is going to be exergonic, which is minus delta G. Yeah, so products minus reactants, and we're good. So this is going to be fast, okay? It is a small hill. This is the transition state, right? It's less stable than the product, and it's going to be a fast reaction. And then we can put these together, right? And we have 2 transition states, and we have that intermediate right there. Intermediate is the product of one step and reactant of the next, which is low-key going to be this, right? Because that's what we got from the other step. And now in this step, it is the reactant. So it has fully formed bonds in this step, right? Fully formed bonds. So that is going to be our reactant right there as well. So products of first step, reactant of the second step. Transition states are high energy structures involved in the reaction. They are fleeting and can't be isolated, and they are partially formed bonds. The rate determining step is the step that has its transition state at the highest point on the reaction coordinate. So this first one has its transition state at the highest point, right? So the rate limiting step is the highest energy, and that is the transition state.